Okay, so today we're going to look at graphing trigonometric functions. And one of the best things to do when you're graphing trigonometric functions is to look at where the asymptotes occur. So let's have a go at this do now. All right, so what we need to do for this one is we need to determine which one is largest. To help us with that, if we know the values, we can calculate what the values are, but you can go a little quicker at it. If we sketch the unit circle a little. And in the unit circle, tan is positive, negative in these areas. Tan of theta is equal to sine theta over cosine theta. So pi over 3 is going to be here. 2 pi is going to be there. 11 pi over 6. Well, that's 1 less than 12 pi over 6, so that's going to be there. Pi over 6, that's going to be here. So we can see that this one is the largest. Let's do the next one. Minus pi over 4, that's there. Pi over 2, that's here. 2 pi over 3, that's there, but it's negative. And pi, this is here. So this one is going to be 0. This one is going to be, what have we got? This one's going to be 0. This one's going to be negative. This one's going to be negative. And this one is undefined. So the largest here has to be that one, even though it's 0. All right, let's move on. Our goals today is mostly focused around sketching the tangent function and to understand its shape and its asymptotes. So as we saw there, the tangent function is not defined when the cosine value is 0. So if we have the cosine value here being 0, like we do there at pi over 2, the tangent function is not defined. This gives us a vertical asymptote. So we get an asymptote here. Always label an asymptote with its equation, x equals pi over 2. Halfway between those is pi over 4. And at that point, the function is equal to 1. We get a vertical asymptote again at minus pi over 2, because the cosine value is 0 again. Here the values are negative, so at minus pi over 4, it's going to go through 1. Oh, got space to write that. There, at minus pi over 4, it's going to go through 1. Goes through the origin. So these are our 3 characteristic points for reference. And when it comes to sketching the curve, it's going to look like this. This is a cyclical function which is going to repeat itself. So it's going to repeat itself here at 3 pi over 2. We get the asymptote. Always draw the asymptotes first, then draw your 3 characteristic points. The curve looks like this. What is the difference between here and here? The difference between here is the period, how long it takes for it to repeat itself. Now the period for sine and cosine is 2 pi, whereas the period for tangent is pi. So the period here is pi. That means that the asymptotes are going to occur at pi over 2 plus n pi. This is the essential information that we need to know. Here's a little summary of it and of the different coefficients. So A is going to give us a vertical dilation. B is going to be controlling the period. The period is pi over B. B is pi over the period. We can calculate C as the movement of this point here, how it moves left and right. We can also see how this one moves up and down. So the coordinates of this point here is C, D. Looking to see where that point has changed allows us to find C and D. So here's our first example. This can be written in the form of A times B, x plus D. Let's have a go at finding what A, B, and D are. Well, we can see this point here, and this point here. These are our three characteristic points. What we notice is this one here is halfway between the center and the asymptote. So the center here is halfway between the asymptotes. This point is halfway between the center and the asymptote. What we see is that's at 1, so there's no vertical dilation. So A is equal to 1. What we see is it goes through the origin, so C and D are equal to 0. All we need to do is find the new period. The period has been halved. The period is from -1/4 to +1/4. That's pi over 2. So our period is equal to pi over 2. So B is equal to pi over 2. That's going to give us 2. So B is equal to 2. So the function h is defined with the given function. What is the period? Have a go at finding this. Write it in the chat when you're done. Okay, so we can see that B is equal to 2. The period is equal to pi over B. So the period is pi over 2. Let the function g be defined. Find which of the following gives the vertical asymptotes. Have a go at this one. Put your answer in the chat. Okay, so we can see here that B is equal to 1 over 3. The period is pi over B, which gives us pi over 1 over 3, which is equal to 3 pi. The asymptotes are going to be occurring, the first asymptote, because the C value is 0. Because the C value is 0, this hasn't moved, so the asymptote are spaced either side of this point, so halfway across. That means our first asymptote is going to be 3 pi divided by 2. And then our next one occurs at intervals of n3 pi. C. If we know where the asymptotes are, we can sketch this curve. Have a go at sketching the curve here in the interval from 0 to 2 pi. Give you a couple of minutes. All right, let's have a go at sketching this. So start off with, do some calculations down here. Your b value is 3 over 2. So your period is going to be 2 pi over 3. So your asymptotes are going to be at pi over 3 plus n 2 pi over 3. We have no horizontal shift, and we have no vertical shift, so it's going through here. The asymptotes are going to be at pi over 3. So let's work out the scale. We have 1, 2, 3, 4, 5, 6. We have 6 scale marks before we get to pi, so the scale is pi over 6. So pi over 3 is 2 marks. So here. This is x equals pi over 3. Our next asymptote would be back here, so we can show the principal period. This is x is equal to minus pi over 3. Our vertical dilation is a half, so the key characteristic points are here, here, and here. Goes through these points. Then we can sketch it. So the next asymptote is at 2. We have to count 2 pi over 3, so we need 4. 1, 2, 3, 4 scale marks. Here's the next one. This is x equals pi. There's the center. Those are the 2 characteristic points. We sketch. It will then repeat. So 1, 2, 3, 4. That's the center. 1, 2, 3, 4. It's a little bit out of our period. It's going to go like this. It's going to go there. We stop there. Okay, let's have a go at doing it the other way around. So we have to write a function for the transform tangent shown here. So firstly, what I look at first is it's going up like this. So there's no negative value in the value of a. Here is our center. So h and k, c and d are 0. So as it goes through this point here, that means c is 0, d is 0. Here's our characteristic point. It's up at 2. That means a is equal to 2. Then we need to find our period. Our period seems to be seems to be at 1 here and minus 1 here. So the period is 2. So b is equal to pi over 2. So we have f of x is equal to 2 tan pi x over 2. Have a go at this one for yourself. Write the answer in the chat when you're done. Okay. It goes to this point here, which means c is equal to 0, d is equal to 0. It goes through this point here. The y value here is minus 2. That means that a is equal to minus 2. We see that by the reflected shape. Our period is equal to 2 times 3 pi over 2. Twice that distance. So our period is 3 pi. So b is equal to pi over 3 pi. So 1 over 3. So let's write our function. F of x is equal to minus 2 tan x over 3. Whenever you write a function, it should always be well defined. You should always state the domain. So the domain for this one, where x is not equal to 3 pi over 2 plus n 3 pi. That's the asymptotes. That defines the domain of the function. So this is a well-defined function. Okay, modeling question. We got a climber ascending the face. Have a go at this question. I'll give you 2 minutes for this one.
Sir, I have a question about the last one. In the equation it gave us, it says inside the parentheses it's 1 over b. So
yeah,
if rb is equal to...
rb is equal to 3. I kind of ignored that. I didn't want to confuse with how I'd said that b was like this earlier in the questions. And then this question wanted 1 over b, so that you see b as a direct stretch. I think it confuses a bit, so.
Okay.
B is 3 according to that rule. All right, I'm recording today, so I'm going to press on so I finish the video. All right, so what we need to do is we've got, it's 500 foot high, we're going up at 5 feet per minute, somebody standing 150 meters away. So if we describe the viewing angle, tan theta, would be opposite over adjacent. So that would be the height that the person is currently at, and the adjacent is 150. We can also say that the height is equal to 5 times t, based on it's going up at 5 feet per minute, where t is in minutes. This means that tan theta is equal to 5t over 150. That means that t is equal to 5 divided, if I simplify the fraction, I get t over 30. Move the 30 to the other side, t is equal to 30 tan theta. So this is a function that describes the amount of time as a function of the angle of elevation. Does the viewing angle ever reach 75 degrees? Well, the maximum height is 500. So we could put it in up here. We have 500 over 150 is the maximum. So we could find the maximum as the arctan of 500 over 150. Let's use my calculator for that. I'm in radians, so the question was in degrees. I switch to degrees. I get 73. So no. It'll never quite reach. All right. For our exit ticket today, have a quick go at this question. Have a go at sketching the graph.
Sir, I have a question about the last slide.
Okay, let me take that at the end. I'd just like to go through this question here now. So sketching this one, C and D are 0, so it's going through this point here. We need to figure out what our period is. Period is equal to pi over 2 over 3. So the period is 3 pi over 2. And our asymptotes are going to be at x is equal to 3 pi over 4 plus n 3 pi over 2. So our first asymptote is at 3 over 4. So that's here. And here. Our characteristic points are going to go up and down by 3. So that would be halfway between those two at 3 pi over 8. That's not, it's going to be halfway between these two. So it's going to be there. So I'm just going to label that point as 3 pi over 8, comma 3. It's not easy to read. Let's put one in down here. We get our function looking like this. Our next asymptote is going to be at 9 pi over 4. So 9 pi over 4 is 2 2 pi1/4. So that's there. It's going to go through here and there. It's going to continue like this. All right, that's it for today.